Today we're going to talk about something really important in business, comparing profit today versus profit tomorrow. So it is like a choosing between a cookie now or two cookies tomorrow. So first, we need to understand that money today is not the same as money tomorrow. Why? Well, if you have money today, you could invest it and make more by tomorrow. So we need to a way to compare the today's money with the future money. This is super important for businesses that often have to decide, should we make the profit now or invest it to make the more profit later? Okay, so to figure this out, we will use something called discounting and present value. So we will break them down really simply. Let's start with a simple example to understand the discounting. So imagine that you have $1,000. So you may have two choices. The first choice is to put in the bank account that give you 5% interest per year. Another one is you can lend it to the new startup company for a year. If you put it in the bank up to 1 year, you may have the $1,050. Okay, so 1 plus your original money times 1 plus your interest rate. So you may have $1,050. So if you lend it to the startup, they may need to promise to pay you at least $1,050 in a year. Then you may invest. So we can write this as a simple formula. So future value is your present value times 1 plus interest rate. So in our example, your future value $1,050 dollars, and your present value is 1,000 times 1 plus 0.05, which is the 5% interest rate. Okay, so this is basic idea of discounting. So more generally, if you have a sum of the money and interest rate will be R in a year, so it will grow to Y times 1 plus R in a year. Okay, so now let's flip this around. Let's say that startup promised you to pay $1,050 in a year. How much would you be willing to give them today? The answer is $1,000, because if we put the $1,000 in the bank, it would grow to $1,050 in a year. So we call it present value. It is how much future money is worth right now. So we can write down as a formula is your future value PV is your present value is equal to future value divide 1 plus interest rate. So in our example, $1,000 is future value 1,050 divided by 1.005. So to make this easier, we often use something called discounting factor. Okay, so there's a big R, capital R. So it is just 1 divided by 1 plus interest rate. So in our example, 1 over 1 plus 5% would be 0.9524, which is our discount factor with 5% interest rate. So we can say the present value is future value times your discount factor, DF. Remind that DF, discount factor, is 1 over 1 plus R. Okay, so this helps us to figure out how much future money is worth today. Okay. So present value of Z in a year is R times Z. But what if we are talking about money 2 years from now? Okay, until now we are concerned with 1 year. Now we are concerned with 2 years. Let's see how that works. If we put the $1,000 in the bank at the 5% interest rate, you will get the $1,050. How about 2 years? You may have $1,102. Why? At your money in the account after 1 year, then after 1 year, you will get the more interest rate, 1 plus 0.5. Okay, so you may get $1,102.5. So because in the second year, you may earn the interest rate on your original money and on the interest from the first year. So this is called compound interest. So we can write this as future value is present value times 1 plus your interest rate of number of years. Okay. In our example, future value after 2 years, $1,102.5 equal original money $1,000 times 1 plus 0.05 square. Okay, the same works backwards. So if someone promised to pay you $1,102.5 in 2 years, it is worth $1,000 today at 5% interest rate. Okay, so 2 years, if the loan of y we have, so it grows to y times 1 plus r square, and at the previous present, we may define the discount factor is 1 over 1 plus r. Okay, so second year, r square would be 1 plus 1 over 1 plus r square. Okay, so we can tell y over r square. How about t years? A loan over y for t years at interest rate r grows to y times 1 plus r over t. It would be y over rt. Okay, so if we think about another way, the present value of z received in 2 years times is r square z. Okay, if we think about t years, r of t times z. Okay, good, this idea works for any number of years, so we just raise our discount factors to power of the number of the years. Okay, now let's think about how a business might use this to evaluate a big project. Say a project will bring in money over several years. So I will give you an example first. $100 at end of the year, $200 at end of the 2 years, and $300 end of the 3 years. So in order to figure out if this project is worth doing, we need to know what all the future money is worth today. So we do this by calculating the present value of each year's money and adding them up. Okay, so if our discount factor is from 5%, it would be 0.95, which means still about 5%. It would like this. Year 1, 100 times 0.95, which is $95. Year 2, $200 times 0.95 square, which is 180.50. Year 3, $300 times 0.95 of 3, which is $256.5. So total present value is the summation of all of that, $55 plus $180.5 plus $256.5, which is $532. Because this tells us what the project is worth in the today's money. So if it costs less than $532 to start the project, it is probably a good idea. So in generally, in the JET net revenue at the end of the 1 year, JET 2 net revenue at the end of the 2 year, JET 3 net revenue at the end of the 3 year, and so on. So we'll think about T years. So present value of the JET 1 is R JET 1. Present value of the JET 2, R square JET 2. The present value of the JET 3, R over 3, the JET 3. So present value of the T years, R over T times JET T. So in order to get the present value of the revenue stream is, we just summarize each years. Okay, so finally, let's look at the two specific cases that come a lot in the businesses. The case 1 is the net revenue in each period are identical. Then we can get this present value. So what if the project brings in the same amount of money each year for a set number of years? There's a special formula for this, but don't worry about memorizing it. The important thing is that we can easily calculate the present value of all those future payments. So I will give you one example. Here, imagine that you have the lemonade stand. We'll make the 100 profit every summer for next 5 years. Okay, so we want to know what all the future money is worth today. So here's how we think about it. That this year's $100, right? It worth $100. Next year's $100 is worth a little less. Maybe let's say $555. That's next year. The year after that, it was even less, maybe $90, and so on. So we add up all this today's value. Okay, maybe 85, 80. So if we sum all of that, it will be $450. Okay, so let's say someone offers to buy your lemonade stand for $400 today. So if you calculate that, total value of all your future profit is $450. So you know it is better to keep the stand, right? Because for this, that is very useful formula. Okay, so case 2 is the net revenues are constant and perpetual. So now let's imagine that you own the apartment building that makes the $10,000 profit every year. Okay, $10,000. So you expect it to do this forever. So how much is this stream of the income worth today? Here's the cool part. So there are super simple way to figure this out. You just divide year profit by interest rate. Here. So let's say the interest rate is 5%. So here's calculations. $10,000 over your interest rate, it would be $200,000. This means your apartment building is worth about $200 today, based on the future income. Why does it work? It is because $200 in a bank at 5% interest would give you the $10,000 every year forever, just like your apartment building does. So this is really useful for things, just like valuing rented properties and figuring out how much business is worth based on its yearly profit. Or you can calculate the value bonds that pay interest rate forever. Okay.